All right, we're starting week 2 of the Excel labs. So we've been talking about probability this week. So we're going to go ahead and calculate some probabilities using Excel. So let's start with this first tab, which is a contingency table of hire status and sex for some company. So whenever I worked in consulting, I dealt with this in a case where essentially a company was sued because they hired too many males and not enough females. And so I was trying to determine whether there was a statistical significance to say whether more men were hired than women. But we're not really doing quite that. We're just going to calculate some probabilities and kind of get the main idea here. So let's start. So anyway, here on our columns we have hired status, so we have hired and not hired, and then sex we have male and female, and then we've got our totals. So the first step is to complete the table. Okay, so let's start with our total row. Well, so if there are 100 total people, 50 of them are male, well, that means 50 of them must be female, because 50 and 50 make 100. Okay, if there are 50 total males, 20 of them were hired, well then that means 30 of them were not hired, because 20 and 30 makes 50. Okay, and then how many total people were hired? Well, if there are how many females were hired? Well, if there are 30 total hires, 20 of them were men, that means this must be 10, because 20 and 10 make 30. Okay, so that takes care of step 1. Next, what's the probability that a male is hired? Well, let's think about this. We've got 20 hired men, right? Male, hired. And we have 100 total people. So why don't we just do 20 divided by 100? So let's do equals the total number of hired males divided by our sample space, or in this case like an application pool, which is 100 people. We get 20%. So what about the probability a female is hired? So here we have 10 female hires over 100 people in the application pool. So let's do equals 10 divided by 100. And we get 10%. So given that someone is female, what's the probability that they are hired? So notice that this says given that someone is female. Recall that given should indicate that we have conditional probability. So let's recall what conditional probability is. So the probability of A given B is equal to the probability of A and B divided by the probability of B. So let's go ahead and define these things. Let's let A equal the event that someone is hired, and let's let B equal the event of female. So let's write the probability of A, in this case is the probability of hired, which in this case would be 30 over 100, right? We've got 30 total hires out of 100 people. So this would be 30 over 100, which would be 0.3. The probability of B, which in this case is the probability of female, well, there are 50 females out of 100 people, so this would just be 50 over 100 is equal to 0.5. Okay, so how about probability of A and B? So here, let me go ahead. I'm going to come up here so I can just copy and paste. This is a special symbol. Actually, I'll show you how to do this. So we want the probability of A and B. So I'm going to say probability of A. Now I'm going to right-click. No, I'm not. Okay, my cursor is still here next to the A. I'm going to come up here to insert, symbol. We want the intersection symbol. So here in the search bar, I'm going to type intersect. And we want our intersect. So I'm going to use this one right here. So I'm going to double click. We can see it showed up. Now I'm going to exit out of this. So probability of A and B would be equal to the probability of a hired female. Which we already calculated was 0.1. Right, we calculated it right here. What's the probability of female is hired? Well, that would just be the probability of hired female, which in this case is the intersection of events A and B. Okay, so now I think we're ready to calculate the probability of A given B. So we now have the probability of A and B, and then the probability of B. So let's just keep adding on to this. So let's plug in. So the probability of A and B is 0.1, and then we're going to divide by the probability of B, which is 0.5. And this will be equal to 0.2. If you want to double check your math, you can do it to the side. So you could do 0.1 divide by 0.5. Just remember to put your equal sign, enter, you get 0.2. So notice that this is different. The probability that a female is hired is 10%, but given that someone is female, the probability that they're hired is 20%. Okay, so are sex and higher status independent? So let's recall that independence is we have two different ways to determine independence. So the first is if A given B is equal to the probability of A. And the second way is to see whether the probability of A and B is just equal to probability of A times the probability of B. So we'll do it both ways. Let's first find the probability of A times the probability of B, because that's the only piece we're missing. So probability of A is 0.3, and then we'll multiply by the probability of B, which is 0.5, and we get 0.15. Again, if you want to double check that, or if you're confused where this came from, probability of A right here is 0.3, probability of B is 0.5. Okay, and then again, if you want to double check your math, 0.3 equals 0.5 times 0.3, we get 0.15. Okay, so are A and B independent? So let's check this first condition. If A given B is equal to the probability of A. So the probability of A given B is equal to 0.2, right? We found that right up here, 0.2. We need to see, is this equal to probability of A, which is 0.3, equal to probability of A. Well, is this a true statement? No, 0.2 and 0.3 are not the same. So what I'm going to do is I'm going to get rid of this equal sign. And then let's just do insert again. So let's do insert symbol. And I'm just going to search not equal. We can see it's right here, not equal sign. I'm going to double click it and then close this box. Okay, so we know that they are not independent because the probability of A given B does not equal to the probability of A. Now let's just do the other way. So let's see if the probability of A and B is equal to the probability of A times the probability of B. So what I'm going to do, I'm just going to come up here and I'm going to copy and paste the probability of A and B so I don't have to do the whole insert symbol thing again. Paste it here. So we found that this was equal to 0.1, and we need to see, is this equal to the probability of A times the probability of B, which we found to be 0.15, which is probability of A, probability of B. And is this a true statement? No, of course it's not. And so let's go ahead, get rid of this, and then I'm going to do insert symbol, not equal, double click. There. Okay, so are sex and higher status independent? Our answer is no. Why? Because of these statements. Because the probability of A given B does not equal the probability of A, and the probability of A and B does not equal the probability of A times the probability of B. Okay, and then finally, if company X wants sex and higher status to be independent, should they hire more males or females? Well, we can see that there are an equal number of people, or equal number of men and women. However, the higher rate is twice as high for men as it is for women. Therefore, if we want to increase, if we want these higher rates to be similar, then they need to hire more females, because the female hire rate, which is 10%, is half of the male hire rate, which is 20%. So if this had been equal, we would have expected, say, 15 here and 15 here, which would have been an equal hire rate between two groups. Okay, and that's our first Excel lab for this week.